Hello everyone, I got a new setup, as you can see. Bought a new Microsoft Surface tablet, so I hope to post higher quality videos in the near future. And so for the first exhibition of this new tablet's power, I'd like to evaluate black pin red pin's integral in a much simpler manner. So it's so simple that it takes possibly like 2, 3, or 4 steps. And that's simple for calculus, so I hope you enjoy. First off, we're going to let u equal cosine x. And then du is going to be sine x, well, minus sine x dx. And so then that's going to, because we already have a sine x dx right here, we're going to let that be our du, and then multiply both sides by negative, the negative 1. So, now just time to change our limits here. Our limits are going to be, what's the cosine of 0? Cosine of 0 is 1. Cosine of pi is minus 1. So then that's going to be minus the integral from 1 to minus 1 for the inverse cosine of u divided by 1 plus u squared du. And so this is, we can simply change the limits right here, swap them rather. Get the integral from minus 1 to 1, arc cosine of u divided by u squared plus 1 du. Okay. And so now here's the cool part. We're going to, if you analyze the graph, you can note the identity. The inverse cosine of x equals pi over 2 minus the inverse sine of x, or the inverse sine of x plus the inverse cosine of x equals pi over 2. It's the same thing for the inverse tangent and inverse cotangent. So now, just after that, we're going to expand our cosine in this form, or the inverse cosine in this form, get the integral from minus 1 to 1. Sorry about that. We're going to have du over u squared plus 1 times pi over 2 minus the inverse sine. You may ask, why? What's the point of this? Like, the inverse sine is equally, if not more, intractable than the inverse cosine. However, it is not. You see, the inverse sine right here is an odd function. And so, in 1 over u squared plus 1 is an even function. So then it's an odd function in total. And so if we evaluate, or actually here first, let's just expand this real quick. That equals pi over 2 times the integral from minus 1 to 1 du over u squared plus 1 minus the integral from minus 1 to 1 inverse sine of u over u squared plus 1 du. Okay, so you can deduce that this inverse sine term right here, this whole integral just cancels out because it's an odd function evaluated on negative and positive limits. So it just, both of those segments cancel each other out. So this just gets eradicated. And now here's a bit of a simpler method of evaluating this, right? Simpler method of evaluating this right here is that, okay, so you can take an even function on the negative limit to the positive limit, and so here's what you can do. It's going to be the same. So you can say it's just 2 times 0, the integral from 0 to the positive limit, or 2 times the integral from negative limit to 0. And so then we would have 2 times pi over 2 times the integral from 0 to 1 du over u squared plus 1. And so 2's cancel, and then you get the integral for pi over 2 times the integral from 0 to 1 over u squared plus 1. That is the inverse tangent, and then evaluate the inverse tangent at 1. It's, well, oh shit, no, sorry, this should not be pi over 2. Okay, pi times the inverse tangent evaluated at 1, which is just pi over 2, or no, pi over 4 actually. Then you get pi over 4 minus 0 times pi. 0 goes away, and it's just pi times pi over 4. And so that equals, very nicely, pi squared over 4, which is the exact solution Blackpin Redpin gave. However, it took him like 40 minutes to do it, and it took me like 8, I think. Yeah, let me check. Yeah, like 6. I don't know. You should either check your identities or... No, never mind. I'm not going to make a snarky remark. He makes very good videos. So, I hope you enjoyed, and yes, that's it. All right, see ya.